there it is. There we go. Toby, so how was it? Like, the launch, I think we were preparing for this for like quite some time, like maybe 4 months, 5 months, or like, uh, so how did you feel right now, like,
I
about
mean,
it?
there's a lot that's gone into this product, right? I think when your head's down into just building the product, building the features, you don't see. And when you step away from that, and people say, "Oh, that feature's incredible, that feature's incredible," all of those features together, it's impressive. I mean, you don't see that when you're building a thing. You're focusing on that feature, you're focusing on that feature, and it's exciting to have got to version 1 now with all these incredible features that you know you can use in a combined way and build something amazing on top.
Yeah. So, so now that you're here, and I think like there are a lot of announcements, and there's a lot of vision that you have put out, which is amazing. There's a lot for the developers to like distill and like go back, take and stuff. But I would like to really ask like a bit backwards about when you thought about something like change feeds, serial QL, a lot of these features. Do you ever think like oh, it's like one database, but we are talking about so many things. And what are your thought about like when you bring everything together? Uh,
It's a question we get asked a lot. And I actually just asked it outside. Someone said, you're multi-model. Multi-model is this holy grail, but can it be done well? If you look at databases who've done this before, they've taken time series, they've taken document, they've taken graph, and they've taken the way that those are built individually and tried to put them together. I think what we're trying to do at SerilDB is say, look, we like the concept of graph, we like the concept of document, we like the concept of time series, and anything else. But the way we're building it is unique. With our record IDs and the way that you put your data and you query your data in SerilDB is different. So yes, it enables multi-model, but it's not taking the different models and operating in those different ways. So yeah, there's a lot of functionality, but none of that functionality counteracts each other. You can have that functionality in the database. And if you look at features like change feeds and live queries, they're very similar features. They have different, some are suitable for one environment or situation, and another is suitable for another situation. They exist in that way for a reason. And that's important. As a developer, you can choose whether live queries are right for you, but you have downsides to that as well. You can't go back in time and replay changes as it happened based around permissions, because effectively every stream of changes is unique to the person listening to it. With change feeds, you can go back in time, but you don't have the permissions. So implementing all these features, it's important that we're not trying to say, we can do everything. We can do live queries with the ability to go back in time, because that's going to be much harder to build, much harder to scale, and it's probably not going to work in the way that we would want it. So yes, there's a lot of functionality in SerilDB, but what we've built in and what we're building in the future, it's all designed to work in a seamless way and with the performance that you'd expect from a database.
Yeah, that's amazing. So multiple thoughts, but again, one more question on the same lines, right? When you're thinking about this data industry and the databases, data management, and a lot of these categories, like, and where do you see like we are going with respect to databases, especially SerilDB is now like doing amazing things, bringing in several features that people that have existed all the time in different places. But now I think like we have one great maybe data platform or data abstraction put together. Don't know, like there are so many categories defined, but I don't know like where we fit in because we do an amazing job at many things. So like, what do you think about that area, or like talking about data industry in general, like when you have
Yeah.
to talk about it?
That's a great question. It's a hard question to answer as well. Are we a database? Are we a data platform? What is a data platform? You can get database platforms that exist as services running online, but you have to use them online. You can't download them. You can't run them in continuous integration. You can't run them on an IT device. You can't run them on your own servers. And that's a database platform. But also the platform means a system that does a lot, has a lot of functionality, enables you to do a lot of things more simply. I think for SerilDB, we want to be able to run in so many different ways. That's really important because it means that when you're building on top of SerilDB, you can rely on the same behavior and the same functionality regardless of where you're running. So let's say you're building business logic against SerialDB, and you can develop on your laptop, and that's important. And then you want to run that in continuous integration. So you can run that in continuous integration. If you need to then deploy to an IoT device, it operates in the same way. That's important. I think also if you look at the industry at the moment, which is a bit of a bigger topic, you've got analytical databases and transactional databases, and SerialDB is a transactional database. But what you can do with graph data and what you can do with time series data is analytical. Now, that's not to say it's an analytical database. But as we look forward, immutable data is such an important piece of the data industry that no one really talks about because it's so hard to implement. And that is what we're trying to do with SerialKV. So SerialKV is kind of a step one as an embedded version key value store. It'll enable us on a single node to go back in time. Step two, we're going to be building that in a distributed manner so that you can go back in time across your data at any scale. Now, obviously, you're going to be paying more as you store more data. But at the moment, you've got transactional databases that store current data, and you've got analytical databases that store historic data. And you're querying those in very different ways. If you want to query your current data, you go to your transactional database. And if you want to query your historic data, you have to query in a very different way. The data is structured differently and the queries are run differently. And those are typically slower queries. What we want to do with SerialDB is to be able to say, look, I want to run this query with my current data set, but I also want to run this query 6 months ago with the data set that existed 6 months ago without having to go to a different platform, a different system. That data hasn't changed. That data has changed, but the historical data is immutable. So you're not changing the data that existed back then. You're adding to it. And that is really powerful when you take the combinations of time series, which is analytical in itself, graph, which enables you to do analytical querying, and then sit that on top of an historic versioned underlying storage engine because it enables you to go back in time. And I think that's the important point. I think in the future, there's going to be less analytical and transactional database separation. And with SerialDB, we see that being brought together, and it will enable far better applications, especially ones at size, especially if you're a large organization who needs to see your data as it changes over time, maybe for network analysis or for auditing analysis, anything which can benefit from seeing data change over time, that's going to be massive.
Yeah, that's a lot. And again, talking about, I'll come to the querying part, but I also understood that there are so many similar organizations who have attempted to try, or they still exist, like try to do the data versioning and trying to let you query things at different ways, but also like enable you to do the real-time stuff at the right points. It's very interesting. Are you talking about like a storage engine that's really, really powering, or what storage engines that SerialDB can accommodate today into the same paradigm or work with?
Yeah, so that's one of the hardest things, right? At the moment, as I mentioned in my keynote, you can run on RocksDB, you can run on SpeedDB, FoundationDB, TiKV, and IndexedDB in the browser. And those enable you to do all the functionality that you'd expect from a database like SerialDB or like any other database out there. Why we want to replace those, because those work well, right? RocksDB's from Facebook, TiKV's from PingCap, FoundationDB is now owned by Apple. These are big players. Why do we want to replace that? Because what we want to do in order for that versioning of data over time needs to be completely written from the ground up. And then SerialDB can sit on top of SerialKV and enable us to add versioning to the database as a whole and to querying as a whole.
Interesting. Moving ahead a bit, as a developer, I always loved SQL because it enabled me to query the databases, and then then NoSQL came in, and then I started asking questions more in JSON and all of that, and then I know that over the years, terms apart, like new SQL has come in, but I loved SerialQL. As a developer, you can do many things, it looks like, and I see the demos, and then it's more awesome than ever. And SerialML with SerialQL, it's like amazing as well, right? You don't need to every time when you need to learn a new technology or new thing, everything is becoming part of the same thing. So that's amazing. So let us talk about like more about Serial QL, the vision, or your thoughts behind it, and yeah.
Yeah. I mentioned this in my keynote. There was a lot of opinions in the beginning. Why not go with traditional SQL? And we could have done, but that would have meant it would be harder to build in what we want to build in. You could build it with plugins, you could build it with layers. But for us, the programming language, Serial QL is turning into this programming language. You can do more imperative, more programming-like style of querying over your data. And that's important, especially when you're dealing with business logic, or you're dealing with graph queries and things like that. It's much easier to deal with that in a non-SQL way. Don't get me wrong, data analysts, data scientists, they don't want to be doing programming necessarily. They want to be using SQL. So that's important for us to stay in both worlds. Looking forward to the future, we want to make Serial QL even more powerful. The introduction of custom functions in Serial QL with this version was a big step towards that, because now you can have your own functionality, custom business logic, stored procedures. Not really the ideal place to store business logic. We've all been through that, massive stored procedures, thousands of lines long that no one really knows how they work, but no one dares to touch them. But you can build small bits of business logic within the database, and then extending on from that with Serial ML, your models become a function. So instead of having to connect to an external data platform, infer against your data, which is in the database, then bring that in, maybe store the results or act on those results, your model now becomes a function within the database, within Serial QL. And everything is just a function. And it enables you to really simply build, extend, and analyze your data in new ways. Going back to your point at the beginning, new SQL, no SQL. Technically, in the industry, we're a no SQL database. That's obviously changed now. We have an SQL query language, or an SQL-like query language. And this is definitely new SQL. I think nowadays you have so many different database types that those definitions are old. Right? They're gone now. But we definitely see the need to have both. You need to fit within people's programming languages in Python and Node with an ORM-like SDK. You need to have the functionality for SQL as well, and you need to have everything in between, because you need to cater for developers and data scientists and everyone in between.
Interesting. And that puts me into a lot of thoughts, but moving on. About the, before we get to the ML part itself, whenever you have announced more about or we were talking about the vectors and the search features, and you mentioned also about the specific categories. And I also asked you about different categories into Serial DB as well. Let's talk about search, and then and search is to me, search is a very fundamental and a core feature of any database. We query the we query the databases, we query the data, and search is that enables it. So what do you think about this entire growth moving away from? Do you think Serial DB is going to go deep into the more of the search area? You also have vectors, more search features coming in. I think this amazing analyzers area that Emmanuel spoke about.
Yeah.
So yeah,
the work that Emmanuel has done over the last few months has been incredible. Really importantly, we have not built on top of other libraries, and that was mentioned by Emmanuel, but I think it needs to be driven home. We're not based on Lucene, we're not based on Tantaby. These are awesome projects, but we're not built on them. And it would have been a lot easier to build and release on these libraries. But building it ourselves into the engine ourselves, our native indexing engine, it's harder. We've got performance improvements to make over the next few months. We've got implementation details to change. But what we can do is and it comes back to Serial QL, you can completely build the indexing language and the indexing functionality within the query language. We automatically, and going forward we'll support more, but we automatically understand what's happening in the query language itself and can then build on that. If you look at lots of other database types out there, if you're doing a full text search, and vector embedding is slightly different, but if you're doing full text search, you have to usually pass a query, string-like query, into a function, because that string-like query is being pushed off to this full text search indexing engine. Results are being brought back, and then it's pulled back into the database. With us, SerialQL, you write it if the index exists and the support is there for that type of index or for that type of query, then we can automatically jump on that. And that's really important, because that will enable us to be so much easier for all those different developers that I just mentioned, data developers or data scientists. They can all use SerialDB without having to think, or do I need to understand the full text search implementation? Do I need to understand vector embeddings? It's built in there, and it's a simple SQL query to write it, and it's the same SQL query to read it. And that's the same thing with vector embeddings, right? The vector embedding data will sit within the ACID transaction model.
Yeah.
It will sit alongside your data. And then when you add to that with SerialML and you bring the machine learning, especially when we over the next few months integrate with Hugging Face models, and you're able to bring LLM models into SerialDB, you're not having to push your data out into, integrate multiple different platforms together with an API, with business logic sitting in Kubernetes to do it. You can handle everything in Rust runtime, Rust engine that's powerful, that's fast, and it sits next to your data. That's not to say that we want to do everything. That's importantly not what we want to do. SerialDB, and that's change feeds, is a big part of that. We want to sit within the ecosystem of bigger tech platforms and enterprise platforms where we integrate with Kafka, where we integrate with cold storage or backup and stuff like that. And that's change feed is the first step towards that. But for a lot of these use cases that we're building in, it's so time consuming and non-developer friendly to be doing these things the way that people do them nowadays. And that's what we want to change.
Yeah. So let's talk a bit about Rust and the Radix try, that custom Radix try, time adaptive one that we have built, Tori, and then we'll talk about open source as well, like in the limited time.
Yeah. So SerialKV, Apache license 2.0 today. There's a lot of work that's gone into this. It's not ready just yet, but in the future will be. That Radix try is effectively the foundational piece. It's the data structure that sits within SerialKV. That's Tart, which we named it. But that will enable the versioning efficiently over time. So instead of, if you look at other databases, as you add more data to the database, if you're going to keep those versions historically, your database gets slower. So often data might be held for a maximum of 24 hours, or in some cases out there, a maximum of a week. But the more data that's held, it gets slower. That is not how SerialKV works. And coming back to that point about immutability of data, you can't keep things historically for a year, but the more data you store, it gets slower. That's just not going to work. So that data structure is the first step to saying, look, it doesn't matter how much data you've got on this data structure. Obviously, it's going to get larger the more data you have, but it doesn't get less performant the more data you have in any other way than a normal B tree does. So that is one important part. The other important part is, because we're storing all these versions and values historically, we want to be able to have that perform well. And to do that, that's a big point about the separation between the keys, which reside in memory, and the values. With a Radix try, and a versioned Radix try in this case, those keys are more compressed. A Radix try typically stores data much more compressed than a B tree or an LSM tree, and there are less moving parts to it as well. So there's less rebalancing or resyncing or recompressing of that data. So the keys are much more able to sit in the memory while the values reside on disk, and that will it just leads and contributes to what we're trying to do with immutable data.
Okay, amazing. Again, in the interest of time, I think we discussed a lot about database and everything, but the community is what is propelling SerialDB. And then we got I know that we got a lot of requests, PRs, and we discussed that on the stage as well, and there's going to be a talk in the afternoon. But what do you think about the whole developer experience that shaped up SerialDB, and how much of thought you have given when you started seeing people talking about, hey, you should have a cosine similarity feature, and I'm going to write about it, or what did you think about it?
I mean, you said it in the talk, right? The community is is massive for SurrealDB. We grew out of that community. The early days of SurrealDB, that growth that we saw was just incredible, and that fueled us on. You also mentioned, we hired from that community a number. I can't tell you the exact number, but a good number of people in this company now were contributors to the open source version of SurrealDB, and or on libraries that we used or we implemented within the database, and that's so important. But it's also important, you have to listen to what people want, right? You can't just go and build the product that you think is right out there. I've got my opinions, but you have to listen to what people want as well, especially when those are developers that are building against your database. I said at the beginning of my talk, people have used this database in ways that I couldn't have even imagined. Yes, I wanted to build a database platform that was simple, that was easy, that could be used in many different ways. There are people implementing it on Game Boys. I didn't imagine that, and more ways other than that. And because of that, you have to listen. Now, you also can't be directed by that, because otherwise you can end up building a product that works everywhere and doesn't work well. So it's a balance between the two. But the community is important. Ideas, PRs, especially around the Surreal Cloud Query language. People using this language for the first time and seeing having a different take on it. One that we at the company haven't had yet necessarily, and that's really interesting. Also comes back to our Rust API. People are using this in a way that in the beginning I didn't even think of. Having a Rust API was definitely an intention for us, but it wasn't necessarily a big feature that I saw being a big thing. Now Rust API is massive. People building native apps, and I think that comes back to Rust. We love Rust in SurrealDB. The Rust API is such a big feature of SurrealDB now, and everything we're building in SurrealDB almost is built in Rust. Our user interface has had a little delay internally, but we've chosen to build that in Rust, not in JavaScript sitting on top of the database. It's a completely Rust-built user interface, and because of that, there's some really exciting things looking forward in the future. So, yeah, Rust is we're all in on Rust.
Yeah, that's great to hear, and more or less Rust love coming in that area. One last question. I have more and more developers and people asking me like, hey, I'm going to use this one, and then I need some questions. I have some questions, but then like I need some data as well about how it is working more. What are your thoughts about people who are ready to build, like an indie dev trying to start a side project today? What do you suggest with 1.0 and like or an enterprise trying to put that in there, like whatever the system?
Yeah. So look, SurrealDB today is stable, right? We're not changing the API. We're going to be improving it. We're not changing it from a backwards compatible point of view. We're not changing the data storage versioning. All of this is designed now to be stable for people to use. We are focusing now going forward on performance improvements and improvements generally to the query language, the parser, and to security as well. But that over the next few months, that's what we're going to be focusing on. But today, people can start building on this. We've been building applications on SurrealDB before we even launched it internally, and this, for people, SurrealDB already solves many problems. So, also, at the moment, we've been running internally benchmarks in terms of query speed or parsing, but also benchmarks at scale. So running 12, 15, 20 nodes against a distributed cluster and seeing how that scales. And those are things we're going to be releasing this month and over the next few months as well. But this is definitely something that people can get going with and start implementing as we work towards our long-term support of them in the future.
Amazing. I only get more work done. We are enjoying. We're at a nice stage. Just a checkpoint, the milestone, great milestone. More work to be done and more to be shared, and a community waiting. And that's it from this session. Thank you, Toby, for joining and also debriefing. And of course, these talks can go on forever. And we'll see you soon. We'll talk
Excellent.
again.
Well, thank you. Thank you very much.
Thank you.